I'm calling this lesson Angle Anatomy. We'll go over the parts of an angle, like the sides and the vertex. We'll cover the difference between interior and exterior angles, and we will classify angles. One definition of an angle, different rays with the same endpoint. So if A here is the endpoint, we have a ray heading toward B and a ray heading toward C. These are called the sides of the angle. And right here, that endpoint, that common endpoint, is called the vertex. And when you have more than one vertex, we call them vertices. Probably the most clear way to name these angles is by starting at one of the points on the ray, heading back to the endpoint, and then heading to the other point along the ray. So angle BAC or angle CAB, and this little symbol here means angle. We could try to call this angle A, but there could be some confusion on whether we mean this part of angle A or perhaps we mean this part of angle A. I think in this instance it's pretty safe because we have that green shaded area to show which part of the angle we're talking about. Here in this next diagram, F is my vertex and I have two rays coming off of that. We can call those the sides or arms of the angle. I can call this angle EFG or GFE. Notice that the vertex is in the middle for both of those. I can call this angle F, though it's slightly less clear. And finally, sometimes there are multiple angles in a diagram and they are labeled with a letter or a number. Here we're looking at angle 4, so that's an alternate name for this one. Based on these examples and non-examples, how would you define an acute angle? If you said an angle less than 90 degrees, you'd be correct. Right angles, as shown by the three examples on the left, equal exactly 90 degrees, not any more or less. An obtuse angle is going to be bigger than 90, but it has to be less than 180. Finally, straight angles are exactly 180 degrees. Just like right angles are 90. So one more time, acute angles are less than 90 degrees, right angles are equal to 90 degrees, obtuse angles are greater than 90 but less than 180, and straight angles are equal to 180. So whenever we consider an angle as a common endpoint with two rays coming off of it, we're always looking at this interior part of the angle. However, to actually call something an interior angle, it has to be an angle inside of a polygon, which is a closed figure. So where two sides meet, that would be an interior angle. Possible names, angle ABC, angle CBA, or just angle B. So if this was the interior of the angle, it would be tempting to think that this is the exterior of the angle, and that's not actually true. Instead, the exterior of an angle is formed when we extend one of the sides of this polygon, and this would be the exterior, for example. Or here's another example, and yet another. These exterior angles are formed by one side of a polygon and an extension of an adjacent side. There's various formulas we use that involve exterior angles in particular.